This is Dr. Poe, and I'm just going to practice some neutralization reactions. So you can tell something's a neutralization reaction because you've got a full acid, a strong acid that's going to completely ionize in solution, a strong base, so those are our metal hydroxides, reacting, and in that situation, you're always going to make a salt and water. And we always know the formula of water, so that's fantastic for us. So let's do this first one together to get an idea of what you're going to mean. So as long as it's a strong acid and a metal hydroxide, a strong base, then you're going to make water and a salt. So I always start with the formula for water because I 100% know that is always a result. So that water, let's talk about where that came from really quick. There's only one place that there's an oxygen in the reactants, and that's right here. OH is a polyatomic ion, so that's where one of those H's came from. And the second H came from our friend the acid over here, hydrochloric acid. So that's how we got two H's and one oxygen. It's always going to, this OH is always going to become the water, and the H is always going to come from the acid. So when the acid donates its proton, it combines with the hydroxide ion in solution, and it makes H2O. So let's do blue. I like blue. Okay, so then what's the formula of the salt? So salts are ionic compounds, so we have to remember what's left in here in our fully ionized strong solution. Strong acids and strong bases are going to go completely to their ions. So what's going to happen is this Na, which is really Na+, is going to combine with this Cl, which is really Cl-, charges based on periodic table. Those guys are going to combine and form NaCl, and this is a really easy example because when we flip the charges to find the formula, this plus is a 1, this minus is a 1, they cancel out. So that's a really great formula for that. So that's what I mean, and every time we're going to have a salt, we're also going to have a water, and those are the two products of any neutralization reaction involving a strong acid and a strong base. Okay, so now let's go ahead and you can pause and try these on your own. We can go through these other examples. So you can see that it gets a little bit progressively more difficult because of the charge of magnesium. Magnesium is a +2, and hydroxide is always -1, and then aluminum's a +3, and potassium's +1. Okay, so because magnesium is a +2 charge, we see that right there. This OH is a polyatomic ion, so that's why we use the parentheses. Okay, so what we're going to make, we already know the first one, H2O. So that H2O, again, that came from this OH, and we're going to temporarily ignore the 2. We're going to use that information for balancing. Our first example was already balanced. So there's our water, H2O. And so what's our formula of salt going to be? Well, it's going to be what's left. And remembering that magnesium is a +2 charge and chloride is a minus charge, this is going to be MgCl2. Okay, but looking at this junk ain't balanced, so we got to balance it. So let's go ahead and balance it in purple. Okay, so we got 2 hydrogens in the product side, and 1, 2, because this 2 distributes. 1, 2, 3. Crud. We also have 2 chlorines in the product side and 1 in the reactant side. So I think I can solve this with a 2 here. Another problem is that there's 2 oxygens over in this reactant side, and there's 1 in the product side. So let's go ahead and put a 2 here. So now we've got 1, 2, 3, 4 H, and 1, 2, 3, 4 H on the right, on the product side, 2 Cls on the reactant side, 2 Cls on the product side, 1 Mg on the reactant side, 1 Mg on the product side. This distributes, that's 2 oxygens on the, that distributes, 2 oxygens on the reactant side, 2 oxygens on the product side, and we already did H's. So now this is balanced. Hooray! I'm going to delete that little, oops, I deleted too much. Ah, come back. Come back, parentheses, otherwise we'll have the wrong number of atoms. That's 1 unit. Okay, so we got this, and it is balanced. So really the kind of cool trick to remember, the little pattern that you're going to see, is that the 2 hydroxides, remember they made water if we had two, in our initial example, and these still are making water, but we end up with 2 waters. And if we have 2 hydroxides, then we're going to need 2 acids to neutralize them. So let's see if that holds true, and we do 3. So aluminum hydroxide has 3 hydroxides on it, and we are neutralizing that with another strong acid, HI. Okay, and again, you can pause the video and try it for yourself. But I'm just going to go for it, because we know the first product is H2O. Always writing that down 100% of the time. And then the second product is going to be the salt. So the salts that we have left are I- and Al3+. And that's going to combine to form AlI3. And just so you know, I wrote the acid first in every single one of these cases, but the acid could be written second. Maybe I'll rewrite the bottom one, just to show you guys what I mean. The first one's not always, doesn't have to be the acid. I already forgot what that one was. It could be written like that. So remember that the acid is the one that has the H in front, and the base is the one with the hydroxide. I keep erasing too much. Very sensitive. Okay. And then to balance our equation above here, using the aluminum and the, if it was hydrochloric acid, hydroiodic acid? That's fun. Okay. So let's figure out what we need. We've got 3 OHs here, so we're going to need 3 waters. We just know that, because those OHs make the waters. 1 Al on both sides, so that AlI3 is probably fine, but we need 3 I's on this side. Hey, look! So we've got 1, 2, 3, 4, 5, 6 hydrogens, 3 I's, 1 Al, 3 O's, 3 O's. Hey, look! This subscript became the coefficient for the water and the acid. Pattern holds true. Hooray! Okay, last one. This one's challenging because it's got a polyatomic ion there. But just because it looks harder doesn't mean it is harder. We're going to treat this exactly the same as we treated our very, very first example. So H2O is always going to be a reactant, or sorry, product. Keep messing that up, and that's always going to come from the OH, and it doesn't matter if the OH is listed as the first reactant or the second, and the H from here. And that gives us our H2O. And then our second is always going to be the salt, and we're going to consider the charges. NO3 is a charge of -1, K is a charge of +1. So it's going to be, we always write cation first, KNO3. And that's the salt, and we would name this potassium nitrate. Right, and we would name this one, in case we wanted to, aluminum iodide, and magnesium chloride and sodium chloride, just in case you want to practice naming. Okay, I hope that helps, and thank you for your attention.